This lecture video is about composition of functions, and so the composition of two functions has a particular notation, and this is how we denote it right here. It's read f of g of x. So if you have f composed with g, and we use this little circle to denote the composition of the two functions, and you read it f of g of x. And so basically what you're doing is you're taking this function g and you're plugging it into the function f. Okay, so you're just taking the function g and putting it into the function f. So when I think about the composition of functions, I think work backwards. So basically if you have a value for x, you would take that value, put it into g, take that result, and replace it in x. Replace it with the x in the function f. So similarly, we have g composed with f of x, or g of f of x. So that's taking the function f and putting it into the function g. And again, I just think of these as going backwards. So you're going to take x, put it into f, and then take that result and put it into g. So in our first example, we have the function f of x equals the square root of x minus 2, and the function g of x is 3x minus 1, and we want to find f composed with g. So that means that I want to find f of g of x. So I want to take the function g of x and put it into the function f. So what we're going to do is we're going to take g of x, this 3x minus 1, because that's what g of x is, and we're going to put it into the x in our function f. So we're going to take this whole big red rectangle and put it into the little red box. So we want to find f of (3x minus 1). And our function f is the square root of x minus 2, and I just put a parenthesis for the x, and inside of that we want to put the function g, which is this 3x minus 1. And then we want to simplify this expression, and so we have the square root of 3x minus 1 minus 2, which is the square root of 3x minus 3. And you can't simplify that anymore. You could factor out a 3 underneath the square root, but that's not really going to help you do anything special to that, so you can leave it just like that. In our next example, we're going to do g composed with f. So that means, so we're working backwards, so we're going to take the function f and plug it into the function g. So this time we're going to do it the other way around. We'll do this one in blue. So the function f is this square root, and we're going to take that and plug it into this x in the function f. So we want to find g of the square root of x minus 2. And so the function g is 3x, so that's going to be 3 times what our x is, and then minus 1. And what I'm plugging into x in the function g is this x squared of x minus 2. So we have 3 times the square root of x minus 2, and then minus 1. And we can't do anything to simplify this. This minus 1 is outside of this square root, so it just has to stay just like this. And so just notice that these two are not the same thing. So f of g is not the same as g of f. So another way that you might be familiar of hearing about these is FoG and GoF. That's another common term that's used when talking about the composition of two functions f and g. So now this time we have numbers to put in there. We want to find f of g of 4. And I'll just write down our functions. F of x was the square root of x minus 2. And g of x was 3x minus 1. I'm just going to double check and make sure I've got those correct. So g of x is 3x minus 1 and square root of x minus 2. Okay, so what we're doing is first we want to work backwards with this. So first I want to put 4 into the function g. You take that result and you put it into the function f. So first I'm going to find g of 4. So that would be 3 times 4 minus 1. Oops. 3 times 4 minus 1, which is 12 minus 1, or 11. Then we're going to take the 11 and plug it into the function f. So we want to find f of 11. And that will give us a square root of 11 minus 2, which is the square root of 9, or 3. Next, we want to find g of f of 6. So just like when we added and subtracted functions in the last video, we can also use what g of f is. So this was the function g of f, and you could just use this, since we've already calculated it, and just plug the 6 into there. But it's nice for you to also have this conceptual idea of what's happening here. So we're going to take 6, plug it into our function f. So first I want to find f of 6. And our function f is the square root of x minus 2. So that's going to be, I'm going to fix that, 6. 6 minus 2, which is the square root of 4. And square root of 4 is 2. So you want to take what you get for f of 6 and plug that into the function g. And our result from plugging 6 into the function f was 2, so we want to find g of 2. And g of 2 is 3 times 2 minus 1. And that's 6 minus 1, or 5. Okay, so we could plug the 6 into the function that we got up here. 6 minus 2 is 4, square root of 4 is 2, and then 3 times 2 is 6, minus 1 gives you 5, just like we got when we did it. And so you could go ahead and check that if you want. In our next example, we're given that f of x is equal to x squared plus 3, g of x is negative 6x, and h of x is square root of x minus 3. And we've also got this given function capital F of x, which is a composition of these, composition of these 3 functions. So our first example is capital F of x is 36x squared plus 3. So we want to use these 3 functions to try to come up with this, and we want a composition of the functions. So what function could I plug into one of the other functions so that I could come up with a result like this? Well, how could I possibly get a 36? Well, I've got a 6 here, and if I square 6, I'll get 36. So my guess is that I'm going to have to take this and plug it into here in order to come up with this. And also I have that plus 3 on the end, which also hints towards I have to use that function. So my guess is that I have to do f composed with g. Well, what do I get when I do that? So I would want to find f of g of x. And so that would be f of negative 6x. And so I have to square negative 6x and then add 3. And negative 6x times negative 6x is 36x squared. And then plus 3, which is our capital F of x. Okay, so this is f composed with g. In our next example, we have capital F is equal to negative 6x squared minus 18. So what combination of these functions could I use to come up with this? Well, I have a negative sign out front here, which leads me to believe that I might need to use this function g. And then I've got an 18 here, so I'm guessing that I have to use these two functions again, but probably in the other order. So my guess is that it's going to be g of f of x. So let's check and see if I'm right. So that would mean that I would need to plug the function f into the function g. So I would have to find g of x squared plus 3. And g of x is negative 6 times whatever you're plugging in there. So you would want to put x squared plus 3 in the parentheses here. And when you distribute this negative 6, you get negative 6x squared minus 18, which is exactly what we wanted to get. So basically this is a guess and check sort of thing. The next one is capital F of x equals x. Well, I've got a plus 3 here and a minus 3 here, so I'm going to guess that it might be a combination of those two functions. So I'm going to guess f of h. So that would mean that I would want to plug the function h into the function f. And the h of x function is square root of x minus 3. And f of x was x squared plus 3. So we would want to square that. Oops, that minus 3. So square root of x minus 3 squared, and then plus 3. So when you square a square root, you just get what's underneath the square root, so x minus 3, and then plus 3, and we do in fact get x. So f of h works. You might also want to check h of f just on your own, and see if you come up with the same thing. Now we're going to do sort of the opposite. So we've been given some function, h of x, and we want to find the two functions f and g, such that f composed with g will give me this function h. So first of all, f composed with g means that you're taking the g of x function, plugging it into the function f. So you would want to think of this g of x function as being inside, and the function f as being outside. Well, what's inside here? I would say x minus 2. So I would say that g of x is x minus 2. And f of x, what's on the outside? Well, the absolute value bars. So absolute value of x. So then when you take this x minus 2 and plug it into the function f, you'll come up with the absolute value of x minus 2. And our next function, h of x equals 1 over 3x plus 5. So two functions that I can think of that would give this is f of x equals 1 over x, and then g of x would just be this denominator function, 3x plus 5. So then when you plug this g of x in for this x, you would get the 1 over 3x plus 5. And our next one here, h of x is equal to the square root of x minus 2 plus 4. So there are a couple of different things that you could do for this one. So f of x could be the square root of x plus 4, and then g of x could be x minus 2. Oops. And you may be able to think of another way to define f and g so that you would come up with the same thing. But here, if you plug x minus 2 in here, you would come up with the square root of x minus 2 plus 4. And that is the end of our lecture on the composition of functions. Let me know if you have any questions. Thanks.